Well, here's an interesting problem. If we're given the acceleration function and some initial conditions, can we find the velocity and position functions and evaluate it when t equals pi over 2? In other words, where is this thing when t equals pi over 2? In that way, we would actually be able to take the acceleration and discover the behavior, actually with some initial conditions, and then discover the behavior of the function itself.
I want to discuss all this behavior.
Nothing wrong with behavior. So, first of all, if we're given the acceleration vector as negative cosine ti plus sine of tj, we integrate that and say we get negative sine of ti plus cosine of tj plus some arbitrary constant vector that we must remain unnamed. But we have an initial condition, and that's that the velocity at time 0 is j plus k. And so what does that tell us? Well, if this is the velocity, we put in 0, sine of t is 0, and cosine of t, when t is 0, is 1, and that's just what we have from this. So that's good, but this says plus 1k. So therefore, we must have a 1k that was part of this constant vector. And so that is our velocity vector. And the velocity at pi over 2, if you just plug in pi over 2 here, is, since sine of pi over 2 is 1, it's negative 1i. Cosine of pi over 2 is 0, so it's negative 1i plus k. And now, the position function, r of t, the one describing this point moving about in three-dimensional space, well, we know it's a velocity vector, so if we integrate it once, we will get this position vector. So integrating this vector, we get integral of negative sine t is cosine of t, I. Integral of cosine of t is sine of tj, and then integral of k is t times k instead of 1 times k, plus again a constant vector, the vector of constants from each of those integrations times I, j, and k respectively. But we have an initial condition there that r of 0 is equal to I. So if we were to replace cosine with 0, then this would be 1 times I, this would be 0 times j, and this would be 0 times k. So our constant vector is just, since r of 0 is I, our constant vector is just the 0 vector. So our position function r of t is cosine of t I plus sine of tj plus t times k plus the 0 vector, and r evaluated at pi over 2, since cosine of pi over 2 is 0, it's 0i plus 1j plus pi over 2k, and hopefully you can see all that.